Hello, ladies and gentlemen. This is Mr. Cunningham. Welcome to my home. This is where we're going to be learning about metric units and also something called the International System of Units, or SI units. Metric units and SI units are important to science and how we can record and also relay data between other scientists. Scientists all over the world use metric and SI units in order to be able to communicate back and forth. Um, in a way, numbers are kind of a language, and really in the United States, we are using the English system, which is a different numbers language than the rest of the world. The rest of the world uses metric uh, units, and we use English units. So it's going to be important in our class that we use metric units. So what we're going to do today is kind of look at how metric units are set up, and really I think you'll find that it's actually not too bad once you start learning how to use these metric units. So let's take a look at them. So let's take a look at these metric units and how we can, I guess, interpret them. So previously I talked about SI units and metric units. But what I kind of want to do is set your mind at ease and kind of tell you that really they're the same thing. We can use them pretty much interchangeably. If I say make sure you use SI units or make sure you use metric units, I'm really saying the same thing. So SI, metric are the same. And now, I know I might be stretching your brain a little bit, but I'm going to ask you to think back to math class, and there's a specific system that we use to represent numbers with the power of 10. And if you remember, that was scientific notation. So let's kind of take a little review here of what scientific notation is. So here we have a simple problem, 10 times 10. And we know that 10 times 10 equals 100. However, if we wanted to, we could represent 100, or 10 times 10, as 1 times 10 to the second power. So 10 times 10 equals 100, and 1 times 10 to the second equals 100. So that's an easy one, and you're probably thinking, well, why do I need to use that? That doesn't save me any time. It actually seems a little bit harder. Well, if we go to bigger problems, like in these examples, now you can see where scientific notation is very helpful. So in the first one, we have, it looks like, 12 million. Okay, so instead of writing out all those zeros, remember in scientific notation, if we're changing a number into scientific notation, we start where the decimal point is. And at 12 million, the decimal point is at the end. So we count how many spaces we have to move the decimal point in order to make a number between 1 and 10. And we put that number in front. So the number that we created by moving the decimal point was 1.2. So we put 1.2 in the front. Then we find out how many spaces we moved. We moved 7 spaces, so we put the 7 as the exponent on the 10. So to write 12 million in scientific notation, we would write 1.2 times 10 to the 7th power. And now here's how we kind of go the opposite direction. In example 2, here we have 0.0003. Well, we can write that in scientific notation by moving the decimal point until we have a number between 1 and 10. So if we move it all the way to the right, we would end up with 3.0. We move the decimal point over 4 spots. But remember, when we move the decimal point to the right, we have to make the number negative. So we move the decimal point 4 spots to the right, so we make it a negative 4, so the scientific notation for 0.0003 would be 3.0 times 10 to the negative 4th power. So that's kind of just a little bit of a review on how we do scientific notation, and that's going to kind of have to do with how we look at and how we can interpret metrics. So in metrics, I said that they have base units. Now these base units there's tons of base units. So the ones on the left, like meters, liters, and grams, also bytes and watts, you are probably familiar with. You've heard of those. You've heard of bytes. That's like when you're trying to download something. It takes so many megabytes or gigabytes. You've heard of these base units. Watts are a unit of power. So when you use electricity, you're usually using watts. Also, you have joules. Joules are something that we use to measure energy. So these are some base units. These aren't all of them. These are some base units that we will probably be using in our class. So I said that we had prefixes. So these are some common prefixes that are used in SI units or in metric units. So we have from the bottom, or I guess starting from the middle, we have our base unit. So one of those base units could be meters. Okay, so you've heard of millimeters. So if we start from the bottom and work bottom left corner and work our way up, our prefixes are milli, centi, deci, then our base unit, then deca, hecto, and kilo. So you've heard of millimeters or milliliters or milligrams. Okay, so those are all based on these prefixes. So you'll see these the yellow arrows. What that is saying is the base unit can change. Okay, the base unit could be liters, the base unit could be meters, or it could be grams. So if you'll follow the yellow arrow up from the B on base, it has a times 10 and it goes to deca. Okay, what that's saying is if you have a decaliter would be 10 times larger than a liter. If you had a hectoliter, that would be 100 times larger than a liter. And if you had a kiloliter, that would be 1,000 times greater than a liter. Okay, sometimes you might have heard someone say that they have a kilogram, or maybe in the if you watch any movies where they're talking about drugs or something like that, they might say that they have a kilo. Okay, a kilo is a kilogram. Okay, so a kilogram is 1,000 times larger than a gram. Now it can also go the other way. You've probably heard of centimeters and millimeters. Probably you haven't heard of decimeters as much. But what if you'll follow the yellow arrow from the A on base to deci, what that means is a decigram is 10 times, and it's not 10 times larger, it's 10 times smaller than a gram. Okay? If we were talking about meters, okay, a centimeter is 100 times smaller than a meter. It takes 100 centimeters to make a meter. For a milliliter, it takes 1,000 milliliters to make 1 liter. Same thing for millimeters. It takes 1,000 millimeters to make 1 meter. So a millimeter is 1,000 times smaller than a meter. Now at the bottom, you have an acronym. Okay? So this stands for, if you'll look at the red underlining on our prefixes, the first letter of each of those prefixes is the first letter of the word in that acronym. So K in KISS stands for kilo. So this is kind of an easy way to help you remember these prefixes. So kilo, hecto, deca, the base, deci, centi, milli. Okay, you can remember this acronym. Kiss her daily because divorce costs much. If you remember that acronym, you can remember. It can help you remember these prefixes. So let's kind of look, kind of finish up here. What we talked about with prefixes. Okay, kilo, remember, means 1,000 times greater. Okay, So 1 kilobyte is equal to 1, remember the scientific notation, 1 times 10 to the third. 10 to the third is the same thing as 1,000. 10 times 10 is 100. 100 times 10 is 1,000. So 1 kilobyte is equal to 1,000 bytes. Okay, a kilobyte is 1,000 times greater than a byte. Okay, same thing with a milligram. A milligram is 1,000 times smaller. Remember the prefix milli, okay, means 1,000 times smaller. So that's why we put 10 to the minus 3. We're making the gram smaller, so it's milli. So 1 times 10 to the minus third is the same thing as 1 times 0.001. Okay, so a milligram is equal to 1 times 10 to the minus 3 grams, which is the same thing as 0.001 grams, or it is 1,000 times smaller than a gram. Well, I hope that you learned a little bit, at least, about how we can use metric units or SI units in our classes. And hopefully you kind of learned a little bit about the prefixes. We're going to keep kind of practicing these in class a little bit to get more familiar with them so that we'll be able to use them in our classes in order to relay data and the results that we get in our labs. Uh, Thank you for watching, and I'll see you next time in class.